Hello, my name is Jordan Coney, and this summer I worked on nanoscale electroemissions at silicon carbide surfaces. The interest for silicon carbide is to use the defects found in its surface for single photon sources. To do this, we use a scanning tunneling luminescence microscope where we apply a current to the tip and probe electrons to the sample from the tip and a voltage to the sample. This process is called electroluminescence, and the light that is produced from the sample is collected and collimated by a lens at the bottom of the STLM setup. This is then directed to an optical fiber, which is sent to a spectrometer, where we're able to analyze the spectral emissions that were generated from the silicon carbide sample. The silicon carbide sample we use is commercially made and is made up of terraces and risers. The defects we observe in the silicon carbide is mostly found in the risers. Microscopy gives us a top view of the sample. Silicon carbide is a semiconductor that has a band gap that emits in the blue at around 3.2 electron volts. This is, of course, with no defects. With defects in the band gap structure, we are observing emissions in the green. Now, the defects that we are observing in the silicon carbide sample are called N-gap defects from about 2 to 2.5 electron volts. Silicon oxide is potentially the defect in our sample and is mostly observed in the risers. This localized defect could imply greater single photon emissions in our sample. For this experiment, we changed the parameters of the voltage and current applied from the STLM to our sample and our tip, and we got varying results. In the beginning, we just used a constant DC voltage applied on the sample. The DC voltage that we applied was above the band gap of silicon carbide in order to have a tunnel current. When AC and DC voltages are both applied to the sample, we inject electrons and holes. This increases our spectral intensity while measured at 100 Kelvin. Future work in this project involves installing a single photon correlator for light emissions to see if silicon carbide is truly a single photon source.